Very good morning, students. Let us continue our discussion of the subject discrete mathematics, and presently we are learning unit 5 graph theory. Today's topics being discussed are few basics related to graph. We'll start with isomorphic graphs. Okay, so two graphs, let us say this is the first graph and this is the second graph. What we are seeing here, the first graph is having the vertices V1, V2, V3, V4, V5, and the second graph is having the vertices A, B, C, D, E. So we want to check if these two graphs are isomorphic to each other. If these two graphs are isomorphic to each other. Two graphs will be called isomorphic if they are having the same number of vertices, they are having the same number of edges, they will be having the same degrees for corresponding vertices, same number of connected components, same number of loops, same number of parallel edges, one-to-one correspondence between vertices to vertices, one-to-one correspondence between edges to edges, such that incidences are provided or preserved. So let us look at this. Okay, this is the first graph having vertices V1 to V5. This is the second graph having vertices A to E. We want to check whether they are isomorphic or not. So let us see the first condition, same number of vertices 1, 2, 3, 4, 5. 5 vertices are there for graph 1, A, B, C, D, E. 5 vertices are there for graph 2. Number of edges 1, 2, 3, 4, 5. 5 edges are there for this graph. Now let us check here 1, 2, 3, 4, 5. So 5 edges are there for this graph. So both the graphs are having equal number of vertices, equal number of edges. Connected components, you can see the connected component is 1 here as well as the connected component is 1 here. So there are no loops, there are no parallel edges, so the condition is being satisfied. Now we can call these two graphs as isomorphic graphs. Isomorphic graphs. Let us look at the next kind of graph called as a regular graph. Which graph will be called as a regular graph? If in a graph the degree of all the vertices is same. The degree of all the vertices is same. Let us look at this graph. How many vertices are there? 4. What are those vertices? A, B, C, D. What is the degree of A? 2. What is the degree of B? 2. What is the degree of C? 2. What is the degree of D? 2. So all the vertices are having the same degree, that is 2. Hence this graph will be called as a regular graph, and this will be called as a 2 regular graph. This will be called as a 2 regular graph. Let us look at this graph now. Same number of vertices A, B, C, D, but the edges have been increased. Now degree of A is 3, degree of B is 3, degree of C is 3, degree of D is 3. It means all the vertices A, B, C, D are having the same degree, that is 3, are having the same degree, that is 3. So this graph also is a regular graph, and this graph will be called as what? This graph will be called as a 3 regular graph. This graph will be called as a 3 regular graph. What is the order of a graph? The order of a graph is total number of vertices in a graph. Let us say the order of this graph is 4, the order of this graph is 4, the order of this graph is 5, the order of this graph is 5. Just count the number of vertices. That will tell you the order of a graph. Let us go for the next graph called as a complete graph. What is the meaning of a complete graph? Every vertex is connected to every other vertex in a graph. So every pair of vertices is connected to a unique edge. These are the conditions. If these conditions are met, such a graph will be called as a complete graph. Let us look at this graph. How many vertices are there in this graph? 4. What are they? A vertex, B vertex, C vertex, D vertex. Okay. First condition, each vertex is connected to every other vertex. So A is connected to B, it is connected to C, it is connected to D. So all the vertices it is connected. Similarly, B is connected to A, it is connected to D, it is connected to C. C is connected to A, C is connected to B, C is connected to D. D is connected to A, D is connected to B, D is connected to C. So such a graph will be called as a complete graph. In a complete graph, if you want to find the degree of vertices, the formula is n minus 1, where n is nothing but the number of vertices. Let us first check manually degree of each of the vertices. Degree of A is what? 3. B is what? 3. C is what? 3. D is what? 3. Now, let us calculate using this formula. Degree of any vertex is equal to n minus 1. What is n? N is number of vertices. How many number of vertices are there? 4. So 4 minus 1 will be 3. In a complete graph, if you want to calculate the number of edges, the formula will be n into n minus 1 by 2, where n is the number of vertices. So 4 into 4 minus 1 by 2. So 4 into 3 by 2, 12 by 2, so 6. So the number of edges are 6. 1, 2, 3, 4, 5, 6. In your many books, the notation Kn is used to represent complete graph with n vertices. Say for example, this is K1, 1 vertex, K2, 2 vertices, K3, 3 vertex, K4, 4 vertices, K5, 5 vertices, like that. Let us look at the next term called as a bipartite graph. The simple meaning of a bipartite graph is take any graph, partition that graph into two parts. When you partition that graph into two parts, what you will see is, if it is a bipartite graph, the edges from one partition will be connected to the nodes in the other partition. So all that connectivity will be there, but in single partition, the vertices are not connected to each other. So let us say I partition like this. So in one partition I have V1, V2, and in another partition I have W1, W2, W3. So V1, V2 are not connected, W1, W2, W3 are not connected. V1 is connected to W1, W2. V2 is connected to W2, W3, like that. What is a complete bipartite graph? So every vertex of the first set is connected to every vertex of the second set. Take this example. Here what has happened? A is connected to 1 and 2, B is connected to 1 and 2, C is connected to 1 and 2. 1 is connected to A, B, C, 2 is connected to A, B, C. So this indicates this is a complete bipartite graph. What is a bipartite graph again? Let us partition this graph like this. So on the lower partition I have 1 and 2, on an upper partition I have A, B, C. So I can see A, B, C are not connected, I can see 1 and 2 are not connected, but A is connected to 1, 2, B is connected to 1, 2, C is connected to 1, 2. So this is the example of a bipartite complete graph. In such a graph, the order, what is an order? Number of vertices. It will be calculated by P plus Q. What is P plus Q? So here K is P comma Q. P comma Q is what? Left partition vertices, right partition vertices. So 3 plus 2, 5. So the number of vertices will be 5. Now number of edges, how they will be calculated? P multiplied by Q. So 3 multiplied by 2 will be 6. So here the number of edges will be 6. What is a simple graph? Simple graph does not have any loops, does not have multiple edges, does not have parallel edges. It is undirected. What is the meaning of an undirected graph? All the edges are bidirectional. One term is there called a symmetric digraph. In a symmetric digraph, for each edge, say xy, there is an edge yx. A symmetric graph, it will be having only one directed edges. Let us take this graph and let us try to first find the degree of each of the vertex. What is the degree of A? 2. Degree of B? 1, 2, 3, 4. Degree of C? 1, 2, 3, 4. Degree of F? 1, 2, 3, 4. Degree of E? 1, 2, 3. So degree of B, C, F is 4. Neighborhood, let us calculate. Who is the neighbor of D? C. Neighborhood of A? B and F. Neighborhood of E? B, C, F. So this is how you will be calculating the neighborhood. Suppose the degree of a vertex is 0, it is called as an isolated vertex. Suppose the degree of a vertex is 1, it is called as a pendant vertex. So let us stop here with few of the basics of graph theory.